I've got two very special.
Dada, you. It's my name.
It's my me.
Show me.
Show me.
Show me.
Two very special guests here for lesson 11. Everyone is really excited to check out what we're going to be doing.
What?
And Mr. Calaveras is here too. Oh my goodness. Is it exciting, you guys? Hey, you want to know what's really exciting, George? Guess what? Yeah, we're going to multiply with decimals. Can you believe it, Cal? Multiplying with decimals? And, hey, Cal, guess what? Cal, we're going to use, can you tell the kids we're going to use estimation? All right, we're going to use estimation, right, George? And we're going to use, I know, it's so exciting. We're going to use estimation to guide our decimal placements. And, I mean, these kids just could not be more excited. We are going to have a great week in math and let's go ahead and get started and take a look at some examples. Say bye, guys.
Bye, guys.
Bye. Say have a great week, fifth graders.
Bye.
Hey guys, I have been super excited to get to this lesson because when I first learned how to do this a few years ago when we started doing Eureka, I was just kind of blown away by this strategy. So we are going to look at another strategy for multiplying decimals, multiplying numbers with decimals in them, and we are not going to do traditional algorithm yet. We're just going to add something else, another strategy to our toolbox. This is using estimation, but in a bit of a different way. This is going to rely on our understanding of the place value chart, and this is going to touch base with our knowledge of what happens when we multiply something by 100 or when we divide a number by 100. Just think about, let's look at this here, 2.42 times 100. This number would be moving to the left 2 columns because multiplication, the numbers are going to grow larger. These digits would shift to the left 2 columns because we're multiplying by 100. There's 2 zeros in 100. So what we're going to do, you guys, with these expressions is we're going to temporarily shift the decimal out of decimal form, and here's how. I'm going to rewrite this just because I want to have enough room. So the directions here tell us to draw an area. I know I cut that out, but the directions here tell us to draw an area model if that helps us. And we have thought bubbles here, in which we're just supposed to kind of examine the thought process via this strategy. But let me tell you and show you what we're going to do here. So we have 2.42 times 12. That's the original expression here. What we're going to do here, you guys, is temporarily shift 2.42 out of decimal form. And how can we do that? We can multiply 2.42 by 100. Think about what that looks like on the place value chart. We have 2.42, 2.42 on the place value chart. If we multiply 2.42 by 100, each of those digits are going to shift to the left 2 place values. So our 2 in our ones column is going to hop over 2 spots. We'll end up here. Our 4 is going to hop over 2 spots and end up here. Oh, there's my Nordstrom email. Thank you, Nordstrom. A little busy right now. And then our 2 and our hundredths place value is going to hop over 2 place values. So we did tons of work in Module 2 multiplying decimals and other numbers by 100 and dividing them by 100 or powers of 10. So you guys should be pretty comfortable still with doing 2.42 times 100. 2.42 times 100 is going to be equal to 242. So we're going to temporarily, as I said, shift 2.42 out of decimal form and into whole number form. 2.42 times 100 is 242. Sorry, I'm going over that thought bubble. So what we're going to look at, you guys, is actually 242 times 12. which I know that you guys are very comfortable answering this sort of, or evaluating this sort of problem. Let's just multiply through. 2 times 2 is 4. 2 times 4 is 8. 2 times 2 is 4. This should be cake by now. Second row, 10 into 2. 10 times 2 is going to be 20. 1 times 4 is 4. And then 2 times 1 is 2. So we have 2 partial products. All we have to do here is add them up. We have 4, we have 10, we have 9, and 2. Okay, so 242 times 12 is equal to 2,904. But that's not the exact problem that we were trying to solve. Remember, we're actually trying to solve 2.42 times 12. In the beginning, we multiplied 2.42 by 100 to temporarily shift this out of decimal form, not decimal form, out of decimal land and into whole number land. By multiplying 2.42 by 100, we were able to shift each of the digits into whole numbers. Now, in order to determine the answer to the original problem that we're given, all we're going to do, you guys, is divide by 100. Multiplication and division are what we call reciprocal operations. They're more or less the opposite of one another, just like addition and subtraction are the opposite of one another. If I added 2 to something, so say I add 2 to 1, great, that's 3. If I wanted to undo that, all I have to do is subtract 2, and I have what we started with, that 1. Multiplication and division are the same. If I'm going to multiply something by 100 to temporarily shift these digits out of decimal land, in order to reconcile that, in order to kind of undo it, we're going to divide by 100. And you guys should be you guys should be really comfortable with dividing by powers of 10. And if you're feeling uncomfortable with doing that in your head, just go ahead and write down a place value chart. 2,904 divided by 100. When we divide by 100, each of these digits are going to shift to the right because we are dividing. We are going to shift each of these digits 2 columns to the right because 100 has 1, 2 zeros in it. So let's go ahead and do that. So we'll start here with our 4 and we're going to go 1, 2, drop the 4. We have our 0, 1, 2, drop our 0, 9, 1, 2, drop our 9, 2, 1, 2, drop our 2. So the final answer, you guys, for 2.42 times 12 is 29.04. Isn't that cool, you guys? So cool. This is just another awesome strategy that our curriculum provides for us. Let's try to do this one more time. Okay, guys, we are going to look at another example of temporarily shifting, and this is what lesson 11 is all about, temporarily shifting whatever number has the decimal out of decimal form temporarily, and then in the end we're going to go ahead and reconcile that shift. And we're going to do this all by just multiplying by powers of 10. In the end, we're going to reconcile by dividing by powers of 10. We're going to have to be critical and analyze how we can shift this number, the 4.13. Right now it has 2 digits in decimal land. What can we multiply 4.13 by some power of 10 to shift all of these digits over to the left so that all of these digits are in whole number form? Well, I think place value charts are super helpful. They give us a really great visual. So let's look at 4.13 and let's think, what can I multiply 4.13? Some power of 10, meaning some power of 10, a 10, a 100, 1,000, 10,000. These are all powers of 10. We are very comfortable with these. What can I multiply? Which of these powers of 10 can I multiply 4.13 by so that all of my digits are in whole number land, meaning they're all showing up to the left of the decimal? Well, I would need this 3 to hop over, let's look, 1, 2 spots. I know when I multiply something by 100, because there are 2 zeros, I know that the digits will hop over 2 spots. Okay, very cool. So let's go ahead and see what happens when we multiply 4.13 by 100. I know each of these digits is going to hop over 2 spots to the left because we're multiplying. So let's go ahead. Some of us might be doing this in our head by now, and that's fabulous. The place value chart is also a wonderful tool. So please just think about whatever works for you at this point in your learning. When we multiply 4.13 by 100, we're going to end up with 413. So temporarily, we're going to multiply 4.13 by 100 to shift it out of decimal land and into whole number land. This is just temporary. We will take care of this, we'll quote unquote undo it at the end by dividing by 100. The reason why we are temporarily multiplying 4.13 by 100 is because numbers without decimals are a whole lot easier. Yes, I'm going to use the E word to multiply the numbers with decimals, because we can just go ahead and multiply the 7 into 314 and then our 30 into 314 pretty quickly. So let's go ahead and do that. 3 times 7 is 21. We've had tons of experience here with multiplying. 7 times 4 is 28. Second row, we're looking at 30 times 3, which is 90. And then we have 3 times 1, which is 3. Isn't it just kind of refreshing doing multiplication? That's pretty simple. Now we have 2 partial products. We're going to add those up and see what we end up with for our final product. We have 8 plus 3 is 11, plus 1 more is 12. We have 5 here, and then we have a 1. So 413 times 37 is 15,281. Are we looking for are we looking for 413 times 37? No, we were looking at 4.13, remember? Oh, and you guys, these thought bubbles, we're supposed to be communicating our thinking, and I'm actually communicating our thinking outside of the thought bubble, which is totally fine. If you want to squish your thoughts into this bubble, that is totally fine. I have a lot of thoughts, and I cannot fit them all inside this thought bubble, so I will just make it a happy cloud thought bubble. And because this thought bubble is so happy because it knows all of this amazing thinking that's going on around it. Okay, you guys, so we multiplied 4.13 by 100 to shift it temporarily out of a decimal form and into a whole number form. How do I undo my multiplication of 100? What is the reciprocal, the opposite of multiplication? It's division. And so if I'm going to undo my multiplication of 100, I'm going to have to divide by the same, by 100. Okay, we can do that. A lot of us are doing that in our head right now. I'm going to use a place value chart to support our thinking. I'm going to quickly jot 15,281 on this beautiful place value chart. And we're dividing by 100, friends. Think about what happens when we divide something up. If I were to divide a pizza, instead of eating the whole thing by myself, instead of a whole pizza, I'm going to have a fraction of a pizza. I'm going to have less than a whole pizza. When we divide a number up, it's going to eventually get smaller because we're dividing this number, 15,281, into 100 equal pieces. You guys know when we divide, we're going to travel this way because the number will get smaller. When we're dividing by powers of 10, very simply, we're going to shift each of these digits to the right 2 place values because 100 has 2 zeros in it. So let's start here with 1. We're going to hop over 1, 2 place values to the right and drop the 1. Now we have an 8. 1, 2 hops. You will land there, my friend. Let me see if I can increase the size of this. There we go. 2 is going to hop over 1, 2 place values to the right. I'm going to go ahead and bring down my decimal so we don't forget that in all this excitement. Let's take our 5 and hop over 1, 2 place values to the right. And then 1, we are not going to leave you behind. We will shift you down as well. So what I'm seeing, my friends, is 15,281 divided by 100. Again, this divided by 100 is the reciprocal of multiplied by 100. We multiplied 4.13 by 100 so that we can multiply a nice whole number. No offense, decimals, you're fabulous, but it's just easier to multiply whole numbers by whole numbers. So that's why we did this temporary multiplication of 100, but we have to make sure that we rectify that here in the end. We divide by 100 to undo the multiplication that we used at the very beginning. So 15,281 divided by 100 is equal to 5281, which means our final answer is 52.81. So darn. Okay, mathematicians, let's take a look at one pretty straightforward word problem before we wrap up our practice in L11 today. I don't think I've ever seen a more simple word problem coming out of Eureka, so thank you for this. A slice of pizza costs $1.57. How much will 27 slices cost? Oh, it looks like we are going to have slices for everyone plus Mrs. C. Woohoo! Let's figure out who's paying for this. Crew, thank you. That is so generous. Let's see how much Crew is going to have to save in order to take us all out for pizza. Okay, so let's look at one happy slice of pizza. It's kind of a modern take on a slice of pizza. So this slice of pizza is going to be $1.57. We need more than one slice of pizza. We need one for everyone in our class plus your favorite math teacher. So that's going to look like 27 slices of pizza. 27 slices of pizza. So what is the expression that would support this situation? Well, it looks like we have 157 27 times. 27 copies of 157. One slice of pizza costs $1.57. We're not just looking for one slice of pizza for Crew. He is actually going to pay for all of us. Everyone in the class plus me. Woohoo, thanks, bud. How are we going to use the strategies that we've been practicing in the lesson 11 to figure out the total cost of this pizza? Well, here's how. We are going to temporarily 157, don't panic on me. We're going to temporarily shift you out of decimal land and into whole number land. Here's how. It's not even going to hurt. We're going to multiply you by 100. Because I see there are 1, 2 place values to the right of the decimal. When I multiply $1.57 by 100, I'm thinking a lot of you are realizing this already, but I'm going to show you the place value chart because it's just such a wonderful tool. We have 157 multiplying by 100, which means each of these digits is going to shift to the left twice because there's 2 zeros in 100. We have 1, 2. Pop here. 5 is going 1, 2 over. And 1 is hopping 1, 2 over. So $1.57 times 100 is 157. We are now going to multiply 157 by 27 because it's just darn easier. And we are very busy and very important, and we want to make life for ourselves as easy as possible. Keep in mind, we are going to account for this before we post our final answer. Okay, don't forget that the opposite of multiplication is division. And in order to undo this funny business that we're working here, we're going to divide it by 100 and all will be well with the world, okay? 7 times 5 is 35 plus 4, 39. Did you guys notice I got much quieter in my house? Yes, because Georgie is down for a nap. And I'm hiding in our bedroom. 7 times 1 is 7 plus 3 is 10. Let's go down to our second row where we're multiplying 20 into 7. Well, I know 2 times 7 is 14. 20 times 7 is 140, which means I'm going to have to carry the 1, which means I should have crossed this out because I'm finished with them, and I'm finished with you as well, 7. It was fun. 2 times 5 is 10, plus 1 is 11. 2 times 1 is 1, plus 1 is 3. Okay, let's go ahead and add up our two partial products. We have 9 plus 0 is 9. 9 plus 4 is 13. We have 2, and then we have 4. Wow, that's a lot of money for pizza. Oh wait, no, we have to do something. What do we have to do? Oh, we're looking for 1.57 times 27, not 157. I multiplied 1.57 by 100, so I wouldn't have to multiply with decimals. Now, in order to undo this, we have to divide by 100. Oh, that's right. Division is the reciprocal of multiplication. So as long as I divide by 100 in the end, we're all good because I multiplied by 100 in the beginning. How do I divide something by 100? Well, you can use the place value chart that lives in your heart, or you can quickly draw one with some horizontal and vertical lines. Let's put 4, 2, 3, 9 on our place value chart, and let's divide by 100, which means the digits are going to shift this way when we divide. They're going to shift 2 columns each to the right because there are 2 zeros in 100, and let's see what that looks like. 4,239 divided by 100. Here we go. 1, 2, drop it. 1, 2 means I'm shifting 1, 2 columns to the right because we're dividing by 100. We have 1, 2, drop it. We have 1, 2, drop it. Don't forget to drop the decimal points. Okay, crew, final total. You are so sweet to save your allowance. It looks like you are going to have to cough up $42.39, and we really appreciate that. And safe, thanks for buying us all Cokes to go with this pizza. That's going to be so much fun. I will see you guys tomorrow. I want you guys to tell me tomorrow for the secret word, what is the opposite of multiplication? What is the opposite of multiplication? And what is that fancy word that I used to express opposites? It starts with an R. Multiplication and division are blank operations. This new word starts with an R. Multiplication and division are blank operations. I've used this new vocab word a few times. If you don't know what I'm talking about, rewind and listen again. Otherwise, I am excited to see you guys tomorrow. Cannot wait for another wonderful week in Mathland. See you.